All right, so I've gone ahead and summarized our information from the last video. We've got the point slope form of a line, y equals mx plus b, and we've got the equations of our two lines, y equals negative 1 half x plus 4, and y equals x minus 2. And I've also done a quick sketch of the graph, so we remember what we've got here are the equations of two lines, and they're two lines that intersect at the point 4, 2. All right, but now we're going to start learning some new techniques that will help us if we have equations of lines that don't perfectly cross at nice integer coordinates. So far what we've done is really helpful when we have an easy graph, and we were very intentional yesterday about doing easy graphs of lines, but sometimes we have tough graphs of lines and we still might need to know where the lines intersect. So this is why we are then working on some new techniques. One of the things that we can do, because this equals y and this equals y, we can set these two together and solve for x. When we set them together and solve for x, what do we expect to get? We expect to get 4, because that's where these two lines intersect. So let's see if that happens. So we've got negative 1 half x plus 4 equals x minus 2. So if this equals y and this equals y, then this has to equal this. So we've just written the statement that shows that, and now we're going to solve for x. Fractions are annoying, so often in this case, the first step that I'm going to do is I'm going to figure out what I need to multiply the equation by to get rid of fractions. And in this case, since I've got a 1 half, I'm just going to start out by multiplying everything in the equation by 2. Remember, as long as we do the same thing to both sides of an equation, we've not interrupted the equality, it's both sides are still in balance. So we're going to have negative x plus 8 is equal to 2x minus 4. Phew. Okay, fractions are gone. Huzzah. The next thing that I need to do, of course, anytime we're solving an equation, what does the answer look like? We've isolated the variable and it's equal to some number. So we'll know that we're done solving this equation when we have x alone. And right now we've got a problem because the x's are on either side of the equation. So basically what we've got to do right now is combine like terms. So we're going to add x to both sides, and we've got 8 equals 3x minus 4. Okay, good. Now we've got constants on both sides. We need to combine like terms, so I'm going to move this 4 over by adding 4 to both sides. Now we've got 12 equals 3x. We're very close to having x alone, but we're not done. Right now we've got 3x. So we're going to divide both sides by 3, and we find out that x is equal to 4. Hooray! This is exactly what we expected to get for x, because where these two lines are equal, the x coordinate is 4. So we can see that this is a useful methodology and kind of a cool trick, that at the point where two lines intersect, we know that the equations of the lines have to be equal to each other, and then we can solve for x. Now, if we want to find y, what do we do? Well, x is the input, y is the output, so we can just input that x back into one of the equations. This one is easiest, so I'm going to do that one because I have a choice, so I'm going to do the straightforward one. And so here we know that y is equal to x minus 2. So y is equal to 4 minus 2, which is equal to 2. And again, I'm very relieved because here I can see that the y coordinate of where the two lines intersect is 2. So we can see that this algebraic method is an alternate method to finding where two lines intersect. If we're given the graph, then we can use the graph to find the point. But here we can see if we're given the equations, we can use this method to find the point where the two lines intersect. About one more video.